Today we will be discussing how to simplify radicals. A radical expression is an expression that contains a radical sign. So for example, the radical or the square root of x plus 3, the square root of 9, and 5 square root of 3 are all examples of radicals. A radicand is the quantity or expression under the radical sign. So for instance, in our first example, the square root of x plus 3 then is what you would consider the radicand. On our next one, simply 9 is the radicand. And our last one there, it is 3. So to simplify a radical expression, you remove perfect square factors from the radicand. And you need to remember our perfect squares. So I'm going to make a list over to the side. 2 squared would be 4, and then we keep going. 3 squared is 9, and we keep going and list them all. I'm going to list them up to 100. So 16, 25, 36, 49, 64, 81, and 100. That's not obviously all of them because there's an infinite number of them. I just went up to 10 squared, which is 100. That will help me to do the next step. So on the next part, and I just want to erase this because I want my perfect squares to remain on the screen. To remove perfect square factors, so our first one is to simplify the square root of 50. So I rewrite it and I look over here and see what perfect square will go into that. 25 times 2 is 50. So I rewrite it as the square root of 25 times 2. 25 is your perfect square. The square root of 25 is 5. So you bring it on to the outside because the square root of 25 is 5. I'm still left with the square root of 2. There are no perfect squares left in 2, so my answer for square root of 50 simplified is 5 square root of 2. My second one then is the square root of 192. If I look to see what number will go into that, 16 times 12 will go into that. The square root of 16 is 4, square root of 12. And then I look at 12, the radicand. 4 will still go into it, so I need to go one more step. 4 times 3 is 12. 4 is my perfect square. The square root of 4 is 2. I already had a 4 outside, so I have 4 times 2 now. Square root of 3, which equals 4 times 2 is 8, square root of 3. Now if I look at the radicand, it's 3. No perfect square will go into it, so I know I am finished simplifying that. The next part has variables involved. So the number part, for instance, the 45 is going to work just like what we did up above. So 45 would be rewritten as 9 times 5. 8 to the 5th means I have 5 A's. So I'm going to circle 9. That's the perfect square. And then remember, you have to have 2 of a kind in order to move it out. So I have 2 A's here, 2 A's here. So the square root of 9 is 3. The square root of 2 A's there is A. I have 2 groups that I am moving out. So that is A squared times the square root of, I'm left with 5A. This A is left in here because it doesn't have a partner in order to be moved out. So my answer there is 3A squared times the square root of 5A. Our next one, 27, can be rewritten as 9 times 3. And then we have n and n, because n squared means I have 2 n's. The 9 is the perfect square. My n's this time have a partner. I don't have any left over. The square root of 9 is 3. I have one group of n's that could be removed. So remember to move them out. They have to be in a pair. Times the square root of my leftovers, which this time my only leftover is 3. So my answer there is 3n times the square root of 3. Our next thing that we're going to do is we're going to go ahead and multiply two radicals. In order to multiply them, there are going to be two methods that you can use. The first method you can use is to just go ahead and multiply them. So the square root of 8 times the square root of 12, 8 times 12 is 96. So I get the square root of 96. And then remember, you have to simplify. So you have to ask yourself, are there any perfect squares in 96? And there are. I can rewrite it as 16 times 6. My perfect square is 16. The square root of 16 is 4. I'm left over with 6, so 4 square root of 6. There's no perfect square that will go into 6, so that is simply my answer. The second method would be to simplify each part first and then multiply. So I can rewrite 8 as 4 times 2. The perfect square is 4. The square root of 4 is 2, so square root of 8 can be rewritten as 2 square root of 2 times the square root of 12. The square root of 12 could be rewritten as 4 times 3, because remember, you want to use the factors and one has to be a perfect square. The square root of 4 is 2, and I'm left with the square root of 3. Now you multiply each like part. So the numbers out front, 2 times 2 gives me 4. Square root of 2 times 3 is 6. There's no perfect squares in 6, so again I get 4 square root of 6. So as you notice, these two answers are the same. So you can either multiply and then simplify, or simplify first and then multiply. Both will give you the same answers. If I look at our next one here, I'm going to go ahead and just multiply. 2 doesn't simplify, 10 doesn't simplify, so I'm just going to go ahead and multiply each part. 3 times 4 gives me 12. Square root of 2 times 10 is 20. B times B is B squared. Then I have to look, can I simplify the radicand? I can. I can rewrite 20 as 4 times 5. And I have two B's. So I have a pair of B's that can be moved out. The 4 is a perfect square. I already had 12 out front. Times the square root of 4, which is 2. Times, I had one group of B that would move out. Times the square root of, I had 5 left over. And now I can go ahead and simplify this front part. 12 times 2 is 24. B square root of 5. And that would be your final answer. Our last one here is a real world problem solving. It says you can use the formula D is equal to the square root of 1.5h to estimate the distance D in miles to horizon when h is the height of the viewer's eyes above the ground in feet. Estimate the distance a visitor at the Washington Monument can see to the horizon for the observation windows. Round your answer to the nearest mile. And if you will notice, it just shows you how far the observation windows are up. We are not going to actually account for how far your eyes are off the ground. So we're just going to use the 500. So we don't have to worry about everybody's individual height, which would just change it slightly. So if I look here, I have D is equal to the square root of 1.5 times the height, which would be those observation windows are 500 feet up. If I put that in my calculator, the square root of 1.5 times 500, I would get approximately 27 miles, because it said round it to the nearest mile. Go ahead and complete your quick checks for this section and look at your schedule to find your assignment.